Alright, so question number 6. Alright, angular velocity equation. So we're trying to define what is angular velocity. So the variable that is used for angular velocity, so I'll write that down, angular velocity. So the variable for this is kind of like a W, a curvy W. I forget the exact Greek name for this, but this is kind of the symbol that we'd use for angular velocity. So let's go through the Janine The Tutor's solution. Angular velocity refers to how fast an object rotates or revolves relative to another point, how fast the angular position orientation of an object changes with time. There are two types of angular velocity: orbital angular velocity and spin angular velocity. So here we're giving kind of a general explanation. So essentially how to calculate it is as follows. So angular velocity is the change in the angle over the change in when we're saying theta, change in theta is this angle right here. So in this diagram where you're looking at this angle, so maybe it would start off in this line and then it would move on to this line. So we know the change in the angle over some period of time will give us the angular velocity. And the units are in radians per second. So that's the units for angular velocity. Another way to think about it is using this equation over here. So we can also use speed over radius. So speed is what the object is moving at this point, the vector at that point in time, divided by the radius, so the distance here. We can also think of it in terms of frequency. Frequency is revolutions per second, so angular velocity can also be 2 pi f frequency. So this is often dependent on how the question is phrased, what the givens are, and so on, but usually when I think about angular velocity, this is the main equation I think about. It gives you kind of what it means, what it truly means. So change of the degrees or the angle over some period of time. That's angular velocity, and that's kind of similar to what linear velocity is, right? So velocity, just linear velocity, if we look at it, so we usually represent this by v, so I'll write it down here, is equal to, let me actually erase some space, I'll put it right here. So v equal to change in distance over change in time. So we can see right away how this relates, how these two kind of mirror each other. Here we're using a linear distance or a linear change in position. And then here we divide by time. Here we're using a change in angle, dividing by time to get angular velocity versus linear velocity. So this is kind of a general overview of what angular velocity is and the equation that you can use to solve. Another thing I want to note for this diagram, here we're given also theta is s over r. S is the arc length right here, this distance right here, divided by r. And that gives us the angle right there. So we'll mark this answer as correct. So great work, correct answer. And we'll move on to the next question. I think that's all I want to say for this question.